I'll try to do my best to cover what we missed because of the inconveniences in connecting to you. Today's topic is about tissues. We would begin the first tissue we have in our body, which happen to be epithelial tissue. You know, you have seen about cytology. Cells are somewhere here if you look at our body's organization. Various types of cells are found in our body, but to make tissues, related cells will come together along with non-cellular substance would give us tissue. So tissue is made by related cells and non-cellular substance. We call it extracellular matrix like this. Here you have about 4 cells and non-cellular structures. Some are fibrous, some others are amorphous type of substance. This would give us tissues. Tissues, again, are various types. Related ones are coming together to give us organ. When I say related, in relation to the specific organ. So tissues are making organs. Organs come together, again, related ones, to make organ system, and organ system make the organism. So here we have the tissues in our body's levels of organization to begin today to look at it. There are various types of tissues in our body. One type is epithelial tissue, another ones are connective tissue, muscle tissue, and nerve tissue make the basic tissues in our bodies. Under each one of these, we can have sub-tissues. So there are various types of tissues, but these are the basic tissues which make our bodies. So as I said, today's topic would be to look at histology of the epithelial tissue. Again, next, it also happened to look at with me connective tissue. Next time we meet, and then other times you'll see muscle tissue and nerve tissue. Epithelial tissue has its own peculiar features and characteristics, and one of such unique features of epithelial tissue, because of its needed function, is that it is closely bound. The cells are closely bound like this one. All dot-like regions you see are representing the nuclei of the cell. Mind you, under light microscopy, you cannot see the boundaries of the cells. So these are merged. They look like as if they are merged because we cannot see them. The light microscopy cannot see the boundary between one cell and the other cell. But among the contents of each cell, the nucleus is big, you see them. So these dot-like regions are the nuclei. So here you can see it's very crowded cells. These are also another epithelial tissue. The underlying lightly stained is another tissue. It is connective tissue. This region, for example, you also see some lightly dispersed type of cells. This is another tissue. It is a muscle tissue. So in epithelial tissue, the cells are very much crowded. Another feature of epithelial tissue is that they don't have blood supply. There is no blood supply. So for purpose of getting their metabolic need by diffusion coming from another tissue, which happen to be connective tissue. So epithelial tissue comes in close association with connective tissue for at least 2 reasons. One is to get metabolic need they have to get by diffusion from the heavily blood supplied connective tissue. The second reason is that the connective tissue also offers it is physical support. So because of this, epithelial tissue is closely related with connective tissue. With regard to the types of, again, epithelial tissue or functional of for its function of epithelial tissue, we can divide epithelial tissue into 3 types, broad categories. One is that those which are involved in covering and lining surfaces and the cavities. In our body, all surface exposed to either outside or inside should be covered or lined by epithelial tissue. So one of the basic function of epithelial tissue is to cover or line any exposed surface of your body. This surface could be to the outside, like for example, the skin. The skin has its most outer layer made by epidermis, which is nothing but epithelial tissue. The oral cavity, the stomach from inside, the bladder, take any organ which has the surface, like blood vessel. The inner surface is exposed where blood is flowing. All these surfaces should be covered or lined by epithelial tissue. For what purpose? For protection, absorption. In some cases, like for example, those epithelial cells that are lining the roof of the nasal cavity are, for example, involved in smell. So you see, covering is also related for sensation. Another group of epithelial cells are for secretion as glands. So the glands we have in our body are largely epithelial tissue. And a small, excuse me, small minority of epithelial cells are contractile, like this ones indicated by the green outline. Look at this cell. It has a cell body and several processes to surround a capillary. And by surrounding this capillary, it offers one, support. Second, because it contracts, when it contracts, the flow of blood vessels, the capillaries would be regulated. So in this type of manner, some small number of epithelial cells are functioning as contractile cells. We call this myoepithelial cells. Myo is referring to muscle. They are epithelial cells which are acting like muscle. So you see, epithelial tissue has three broad categories. One is lining or covering, second is secretion, third is contractility. Now let's look at the characteristics of the cells which makes them able to carry on such listed function. When you look at the epithelial cells, I told you this is a diagram of epithelial cells. I told you that the cells are crowded. Inside this lightish grayish outline is connective tissue. You don't even see a cell here, but assume there are cells, but not as much as this one. This one is epithelial tissue. This one is also epithelial tissue. So the cells are crowded. And these cells are polar. They have at least three surfaces. One surface is facing the environment outside or the interior of a cavity. We call this apical surface. It is here indicated by number 1. Then a second surface is the basal surface, the opposite surface. We call it basal surface. And the surface that are facing neighboring cells are lateral surfaces. So epithelial cells have three surfaces: apical surface, basal surface, and lateral surface. And to meet their function, depending on the type of epithelial cells we have, some of the epithelial cells have the following type of apically located structural modifications. Some have microvilli, some others may have stellocelia, some others may have cilia, some others may have flagella. But that does not mean that all and every epithelial cells should have to have any one of these on their epithelial, on their apical surface. That's not the case. Instead, I'm saying in some of the epithelial cells on the apical surface, you may see any one of this surface modifications. Are you with me? Those of you who may be outside, okay, I can see you. All right, okay, thank you. Okay, I'll continue. So let's now look at each one of these. Let's begin with microvilli. Microvilli is a plural form of microvillus. Villus is a projection. We have a villus from the surface of the plasma membrane of the apical surface of these cells projected out to about 2 micrometer in length and just less than 0.1 micrometer in width. They are very tiny. These are not visible distinctly by light microscopy. They are, however, visible by electron microscopy. When we see them by electron microscopy, they are erect like this, like this. This lower part is part of the cytoplasm of the cell. This is the plasma membrane of the cell. From the plasma membrane, look at projections of the membrane is running out. They are in thousands from one cell. They look like this one. Not even this one. They are very tiny, micro, this one, the lower one, this one, in this diagram. In a cross section, they look like this. They are bounded by plasma membrane, and in the core, we have protoplasm extending into the core. Within the core, in order to make this microvilli erect, we need to have microfilaments, mainly actin containing microfilaments are linked one with another, and these microvilli are running from more apical aspect from an amorphous type of region deep into the apical aspect of the cell, where we again have plenty of filaments. We call this a terminal web. So from terminal web to up to the tip of the villus, we have the supporting microfilaments. And all this is in order to increase the surface area of such cells. So the function of microvilli is to increase the plasma membrane's surface area. You can now expect this type of microvilli need to be located or found in cells that are involved in exchange of substance or absorption across the surface. So that's the whole purpose. So they are to increase surface area. I told you we cannot see this by light microscopy. But when they are covered by glycocalyx, you know glycocalyx is a carbohydrate projection from the plasma membrane. Along with the glycocalyx, the microvilli appear to you under light microscopy as faint striations from the upper part of the plasma membrane. Mind you, look at this one. This is a structure within our small intestine. I took it just as an example. Here is a cross section of a structure within a kidney. And all these are epithelial cells. Look at this nuclei. These nuclei belong to adjacent epithelial cells. Here you can see these are the nuclei. This dense outline are all the nuclei. The core here is a connective tissue. So here you have plenty of epithelial cells lining one upon another, and this one are found, for example, in a small intestine from a structure named as villus. I didn't say microvillus, it is a villus. It is another structure. Again, for increasing surface area, we have the layers, the inner layer of small intestine is folded. It is projected again to give us villi. We name this one villi, but I am not in the villi now, I'm in the microvilli. Here also there is a tube, and this tube is lined by cells. And on top of this, we have the microvilli appearing like this, faint striations. And we call this, when the villi are of uniform length, we name them as a straight border. When the microvilli are not of uniform length, they would give us what are named as brush borders. So that's all we see by light microscopy. But under electron microscopy, you can see them very clearly in cross section appearing like this, in a longitudinal section having such an erect outline. So that's what microvilli are for increasing surface area. But in some other cells, few cells, the microvilli are cylindrical and branching because they are long and cylindrical and branching and they are not uniform. They are named as sterocelia. They are not cilia, but the name is misleading. They are microvilli because cilia and the microvilli are different. I'm going to show you the structure of cilia. I've already shown you the structure of microvilli. So these sterocelia are modifications of microvilli, we have them in few cells. In some other cells, which are now not to increase surface area, but they need to move some substance on top of them. Like, for example, those covering our nasal cavity, on the top of the nasal cavity, there is a mucus strategically placed. And this mucus is meant to trap dust particles from the air we are breathing in. And this dust particle trapped within the mucus should be removed by beating, by beating. So for that purpose, the apical plasma membrane of such cells have what are named as cilia. Cilia are tall, they are long, they are wider, they are bigger, and they are tall as this one in diagram. And they are made by plasma membrane projection with core of this time cytoplasm containing microtubules. You remember from our discussion of last module, microtubules are for sliding one upon another and causing bending and straightening. By doing so, they can beat towards one direction, and these are cilia. They have microtubules, not microfilaments. So they are different structurally with regard to size and the function. And this cilia have the root, which is nothing but same as centriole. You go and revise your centriole. And the shaft has only two microtubules in the center, surrounded by 9 pairs of microtubules. These are the structure of cilia, and such composition would enable these projections to get bent and straightened. By doing so, they are able to move structures present on top of them. We have in some cells. Some other cells in us, in mammals, they are present, but in other mammals. In us, we have only on sperm cells what are named as flagella. We have only one flagellum, and this flagellum structurally is same as cilium, but it is much longer. So when cilia are long and are restricted to a few cells, like for example in sperm case in humans, these are named as cilia, flagella. Structurally, cilia and the flagella are just similar, but only differ by length. Then I have to quickly show you what we have such structural modifications on the lateral surface. I have finished about the apical surface modifications in some epithelial cells. Again, on the lateral surface of some epithelial cells, we have structural modifications for purpose of connecting them together. I told you epithelial cells are highly crowded together. They are sitting in such a crowded nature because of one, electrostatic forces generated from the plasma membrane of each cell, which makes them keep at a distance of only 20 nanometer apart. But in addition to this electrostatic forces which hold them together, we have in a given region, most apical region of the lateral surface, structural modification, which are meant largely for connecting one cell with another cell, as well as in one case, gap junction, in addition to connecting one cell with another, to communicate the content of one cell with another cell. So we have such structural modifications on the lateral surface of epithelial cells. If I take you briefly in each one of this, the first one is, I told you, tight junction. It is also named as zonula occludens. Occludens means it is a barrier. So it has an additional function, not only to hold cells together, but also to act like a barrier for substance not to pass between cells, like this one. Look at this. From the basal aspect, substance can flow freely between the cells. But when it comes to the point of zonula occludens, it cannot. So this zonula occludens has two functions, one attachment, two acting like a barrier. And it is also zonula. The term zonula is referring to like a belt So right at that location, the epithelial cells are held to each other to all cells that are found in that location. So it is like a belt. It is not like point to point. So epithelial cells, think of them like found like this. Here you see, you only see the front cells. The front cells are linked one with another with adjacent cells. In that case, you can see it linked to the right or to the left cell. But what about to the cell located behind? What about to the cell located in front? They are all connected at that specific location by the tight junction, which is running like a belt all around the circumference of the cell. So that's what tight junctions are. So because of their nature, they are named as zonula occludens. At such points, the outer plasma membrane, the leaflet of the plasma membrane, come in contact to about 2 to 4 points and making them only separated by about 1 to 3 transmembrane proteins like this one. This is a tight junction. You see, at about 3 sites, they have now come in contact. And right at such a location, transmembrane protein. I told you, you remember from last module, on the plasma membrane, we have proteins that may cross the plasma membrane. When such protein crosses, this protein has cytoplasmic end as well as, sorry, let me answer this question. This, hello, ሶረሳ አቤት ተስተካክሎ ሌክቸር እየሰጠው ነው። አመሰግናለሁ። ኦኬ ታንኪው። አሁን እነሱም እየሰሙ ነው። ይኸው ምስጋናህን የእነሱንም ላንተ አደርስልሃለሁ። ኦኬ ኦኬ ታንኪው። ኦኬ it is Ato Soresa who is just following whether we have managed to conduct the lecture or not. So you have heard I have extended our thanks to him. So you see, these transmembrane proteins have an inner end and an outer end. The inner end is linked to cytoskeleton of the cell. In this case, in tight junction, the cytoskeleton linked are microfilaments. But the external end is fusing, making bond with another such transmembrane protein coming from adjacent cells. Such transmembrane proteins are about 40. They are plenty, they are different types. And out of this, the most common ones are occludin and claudin, are transmembrane proteins which are fusing in between the adjacent cells. So you see, this type of transmembrane proteins are not linking only the plasma membrane, but they are also linking the cytoskeleton. Because I told you from inside, the cytoskeleton, specifically at this location, actins are linked to the intracellular end of this transmembrane proteins. So you see, the actin of this cell and the actin of adjacent cells are also held together. So you see how strong such a communication, such attachments would be. And I told you this tight junction is also a barrier. So acting like a barrier, it cuts the paracellular environment into two. This cell, for example, can have free movement of substance on up to this location, having on the lateral surface as well as basal surface freely moving, but when it comes to such a tight junction, it cannot move. And those which are found above are also moving. So because of this, tight junctions are said to divide the circumference of the cell or the surrounding of the cell into an apical and a basolateral compartment. So this basolateral compartment is just free to move. It also includes the plasma proteins of plasma membrane, and the apical ones are also free to move. But when they reach here, they cannot pass. So that's what junctions are. Their functions include cell-to-cell attachment as well as acting like barrier. Then intermediate junction. Intermediate junctions are zonula, same as tight junction, zonula, but they are not occluding, they are not barrier. Instead, they are just adhering. They are just only meant to connect cells together because there is a gap of about 20 nanometer left. So the plasma membranes are not brought close together as that of tight junction. Again, they have transmembrane proteins which are linking, again, cytoskeleton, which also happen to be microfilaments of adjacent cells together. So intermediate junction are only for cell-to-cell attachment. They are linking not only plasma membrane, but also cytoskeleton. They are linking are again microfilaments. I'm going to tell you about the third type of cell attachment, which happen to be macular adherence. Macular adherence are named as macula. Macula means point. It is point-to-point attachment. So it is not belt. You see, adjacent cells need not to be connected right at one location, but they can be located at multiple sites. When they are to be connected, the connection is not in a circumferential type of manner, but it is to a disc-like manner, disc to disc. Two cells would contribute some structures, and with reciprocal structures, they are linked together. And it is not zonula, it is point to point, it is macula. This macular adherence is also named as desmosomes. And in these desmosomes, the cytoskeletons that are linked are intermediate filaments. You see, I told you, I told you the previous ones are linking microfilaments. But I'm saying these ones are linking intermediate filaments. If I ask you which ones are stronger, there is no doubt that you have to answer macula should be strong because they are linking the strongest cytoskeleton of the cell. You know from the last module, intermediate filaments are the strongest. So they are linking the strongest cytoskeleton of the cell together, whereas the previous two are linking the weakest cytoskeleton of the cells. That's what desmosomes are. The okay location of the function, the basic function of macular adherence is therefore to connect cells where this type of cells are located in regions that are subjected, like for example, cells that are found covering our skin. In such cells, there is repeated tension coming from our day-to-day activities. So this type of cells have to be linked together tightly. When I say tightly, it is not, I'm not saying about the tight junction, but I'm just referring to the strong type of attachment. And for this type of attachment, the type of cell attachment is macular adherence. I'm also telling you that this macular adherence are located at a multiple location. And then below, these are all going from apical to basal in such listed order. These are also named as communicating junction, electrical junction, and others because they are also to link this time not the cytoskeleton, but the cytoplasm of one cell with another cell. Because the connections is to be effected by tubes. These tubes are cylindrical, made by proteins. These proteins are again transmembrane type of proteins, and they are found like this one as patches, as multiple all along the lateral surface in that given region. They come as multiple. Here is one gap junction, another gap, another gap, another gap junction. As connexon. Read this. Conneoxon is is pronounced as connexon. Each connexon is made by 6 subunits. I told you it is hexagonal. And this hexagonal protein connexon is made by 6
proteins named as connexin. You see, this one is I, this one is O. Connexin and connexin. These connexin are lying peripherally, leaving a gap or a pore of about only 2 nanometer. And similarly, another such a protein comes out of the adjacent cells to fuse in the intercellular space. And this intercellular space is in about, again, about each one is protruding out for about 1.5 nanometer. So these cells are separated by 2 times 1.5 nanometer. And these tubes are linked. So one, they are connecting one cell with another cell. They are connecting the plasma membrane of one cell with another cell. So they are attachment. The second one is because they have a hole in the center, substances with diameter less than this much size, and if the charge allows, could flow from one cell to another cell, such as small hormones, amino acids, AMP, and ions, GMP, can be communicated between the cells. So this also have two functions: tight junction to function, gap junction to function, and other ones have one function. This type of structures are not visible by naked eye, by not let alone naked eye, by light microscopy. And because of this, by light microscopy, they could only be appearing as something dense structure, as a bar, and they name them as a terminal bar. When it comes to electron microscopy, they could be visible as, again, densities separately. So you can see this is part of another one cell, here is part of another cell. These ones you see at the apical aspect are microvilli. So these are microvilli. And here you can see a space. This space is the space between one cell and another cell. And look at towards the apical aspect of this adjacently located cells, you can see three densities: number 3, number 4, number 5. If I ask you to label number 3, I know you have to label it as a tight junction. Number 4 is intermediate junction. Number 5 is desmosol. So these three are usually coming together as junctional complex. And studies from biochemical aspects would tell us that how they are formed. Those proteins I told you, those cylindrical type of proteins I told you, are not visible by electron microscopy. They are just descriptions of another studies from different angle. So structurally, from histology aspects, that's all we can see. So under electron microscopy, they are named as junctional complex. By light microscopy, these are named as terminal bars. Then the basal surface. The basal surface is the surface that is facing another tissue. I told you usually the next tissue is connective tissue. In some cases, epithelial tissue of two epithelial tissues may come together. But usually, the epithelial tissue is a basal surface, is just is the interface between epithelial tissue and a connective tissue. And in this region, right at the junction, there would be contribution of both epithelial tissue and the underlying connective tissue to form extracellular matrix. I told you tissue is made by cells and non-cellular substance. One of such non-cellular substance is located right at the basal aspect of epithelial tissue, and it is named as basement membrane. By light microscopy, you see it as a dense layer. When you study it under electron microscopy, you see what is contributed by epithelial tissue and what is contributed by connective tissue are visible. And what is connected from epithelial tissue aspect is named as lamina lucida. Lucida means a lighter zone. And another one is named as lamina densa. So under electron microscopy, the epithelial cells would contribute a lighter zone and a denser zone. These two are measuring about 50 nanometer each. And these are just nothing, don't consider that they are something um, unusual thing, but they could be transmembrane protein. From this cell, a protein may be protruding out, or it could be just a secretory product. So this is visible, these are visible as lamina lucida and lamina densa, and these are together named as lamina, basal lamina. We name them basal lamina. So epithelial cells are contributing basal lamina. On the other hand, from the inner aspect, connective tissue would contribute what is named as reticular lamina. This reticular lamina is more of extracellular substance, which could be fibrous type of structures, which could be amorphous type of structures, and this would be more clear to you when I describe the connective tissue next time. They are products of connective tissue cells, specifically named as fibroblasts. So under light microscopy, reticular lamina and basal lamina together are named as basement membrane, and they appear as a dense line. That's what we have on the basal aspect of epithelial cells. And still again, we have additional structural modifications. These are named as hemidesmosomes, focal adhesions, and basal striations. These three are equivalent to some of the structures I told you we have either on the lateral surface or on the apical surface. Hemidesmosome is just half of a desmosome. I'm telling you, it is half a desmosome like this. This is because the epithelial cell will contribute what they contribute on the lateral surface. But because at this junction we have only one epithelial cell, the connective tissue has another type of structure. So in this region, we have half a structure which look like desmosome. When we consider it is half a desmosome, you have to think that these are linking the intermediate filaments. So there are strong type of attachment of the basal surface to the underlying connective tissue. This region is the basement membrane. And because it is half of a desmosome, it is a strong type of attachment because it is linking the intermediate filament like this. Transmembrane proteins come, and this transmembrane protein are linked from inside to intermediate filament, from outside to matrix, to non-cellular substance of the basement membrane. Another such structural modifications we find on the basal surface are named as focal adhesions. They are same as hemidesmosomes, but they are linking not intermediate filament. Instead, they are linking microfilament. So these are weaker. These are also attaching the cells to the underlying basement membrane, but they are not strong as hemidesmosomes. So we need, for example, in cells which are more mobile, more of focal adhesion. Whereas in cells which are more of stationary, we need hemidesmosomes. That's their difference. And then the other type of structural modifications we may see in some epithelial cells is for increment of surface area. Same as in the apical surface, the plasma membrane should be folded to increase surface area. In the apical surface, it is the projection. The plasma membranes are projecting out, giving us what are named as villi. We name them microvilli. But in the basal aspect, the plasma membrane is not projecting out. Instead, it is folding inside, giving us what are named as plasma membrane infoldings. So we have not projections, but infoldings. And this type of structural modifications are needed in regions which are involved in actively, sorry, what did I do? So okay, it's now resolved. Actively transporting ions which also need large amount of mitochondria. So under light microscopy, you see only these as faint striations, but under light electron microscopy, you see these ones are formed by plasma membrane infoldings along with the mitochondria. The mitochondria and the such foldings under light microscopy appears as striations, same as the straight border we named for microvilli. Here name it as basal striations. That's what the basal aspect of such epithelial tissue. Then we have more uh, to say in the coming few remaining time about the different types of epithelial tissue. I told you we have to divide. Like, for example, I told you those which are covering and lining. I told you there are also which are involved in secretion, and we don't speak much about those which are involved in contractility. So the remaining time would be devoted to look at those covering epithelium and then those which are involved in secretion. So far, I have told you just briefly what you need to know about the special, unique features of epithelial cells in making epithelial tissue. You can also chat. You can also chat. That's okay. Those of you who may be located outside the library may even speak. Is there anything you comment? Shall I continue same? Shall I move in the same speed? Okay, I can see the thumbs raising. All of you are in the library. No one is from outside. No one is able to talk. Are you all muted? ማንም ሊናገር አይችልም? ምንም ኮመንት አላገኘውም። አቤት? Is there anyone to speak? ሁላችሁም ሚውትድ ናችሁ? Mute all. Mute all. Mute all. No, እሺ ሁላችሁም ትሰማላችሁ። Okay, we are in the library. We cannot speak. Are you all muted? I don't know why. You are all muted. Unmute all. Okay, maybe. Are you now unmuted? Can anyone speak? Okay, you cannot. Maybe, okay, request sent. So there is an administration who may unmute you all. But I cannot unmute you all. So okay, anyway, you can chat. I only see the thumbs raised. So anyway, I'm just moving ahead. I see 93, 92 participants. Okay, so I'm now going. I'm moving. We don't have much time to spend. Let me close the chatting. Let me. Okay, pause this. Okay, sir. Resume. Okay, I will do that. Thank you very much. Yes, we are. Okay, I'll resume. Okay. Now let's look at the different types of epithelial tissue. We can see two types of epithelial tissue. The broad division of epithelial tissue is one into those covering and lining, and the second one is those which are making glands. Those which are lining should not be taught by you now, should be identical. Because I told you the epithelial tissue, those which are covering or lining, could cover the surface of the skin. I also told you we also have such epithelial tissue covering blood capillaries. And those epithelial cells covering the blood capillary should be very thin because they are meant only for transfer of substance across them. So they should have to be only a single layer and should be a type of cells which should be closed very quickly. But those which may be covering the skin should be thick. They have to be multiple layers. The cells should be very tough. So you see the covering and lining epithelium should not be identical. So you see, we need also to have some manner of identification of this. So we have classification of covering epithelium. And the way we classify would be based on two criteria. One is based on the number of layers, because some epithelial cells may be a single layer. This type of epithelium is named simple. But we can have others to be multiple layer, and this type of epithelium is named stratified. So covering and lining epithelium could either be simple or stratified. Second criterion. The second criterion is based on the shape of the cell. Some cells should be very thin so that they are very quickly crossed. And this type of epithelium are flat, we name them squamous. Others are round, we name them cuboidal. Others are tall, we name them columnar. And at this point, in order to look at the shape of the cell, you cannot see, because you cannot see the boundary of the cell, you have to look at the nucleus. Because almost always, the shape of the nuclei follows the shape of the cells. So flattened cells have flattened nucleus, cuboidal cells have round nucleus, columnar cells have tall or oval nucleus. So the shape of the nuclei should be looked at, because I'm going to show you the boundaries of the cells are not visible. I also have begun by showing you one slide where the shape of the cells, the boundary of the cells are not visible, but the nuclei are visible. So the shape of the nuclei would tell you the shape of the cell. So we have three different types of epithelium based on shape. So you see, at least if I ask you now, how many types of covering epithelium do we have? You would answer 6, because you would answer to me simple squamous, simple cuboidal, simple columnar. Again, stratified squamous, stratified cuboidal, stratified columnar. At least 6. But we have more because some are coming again with varieties. Under simple, these are what we need. This time, the blue outline is to mark the connective tissue. The purplish above is to mark epithelial tissue. Look at the epithelial tissue. These are flattened. Look at the nucleus. These ones are diagram. Even you can see artificially made boundaries. But in reality, you don't see the boundaries. But look at the spacing and the shape of the nuclei would be important thing you have to give attention. The spacing is also important. And the level of the occurrence of the nuclei and the shape should be looked at. So these ones are simple squamous, simple cuboidal, simple columnar. This simple columnar usually comes as two varieties. Some have cilia, some have no cilia. So we can split this as ciliated, simple columnar, non-ciliated, simple columnar. These are just as a varieties. Then there is one type of additional simple epithelium which under light microscopy confuses one, appearing as if it is stratified, because the cells are not of uniform shape. These ones are made by epithelia with uniform shaped cells. Suppose, what about this type of epithelium is mixed with this or this? You would see the nuclei located at various locations. I told you in reality you don't able to see the boundary of the cell. So it would appear to you as if The epithelium is made by cells sitting one upon another. As if it is stratified, so it confuses, and they named it as a pseudo-stratified type of epithelium. This is what it looks like. Look at this. All cells are resting on a common basement membrane, but the cells have different shape. And because of this, the location of the nuclei and the shape of the nuclei may not also be similar. And because you don't see the boundary of the cells, this one may confuse you. It is stratified, but in reality it is not, because they are named as pseudo-stratified epithelium. Many of the pseudostratified epithelium are ciliated, so we can have them as ciliated pseudostratified epithelium or non-ciliated epithelium. So under simple, you can have at least 4 types. If you add ciliated or non-ciliated, you may even have more. Usually the cilia are found in those which are columnar or pseudostratified ones. Then when it comes to stratified type of epithelium, this is what they look like. But there is one problem now arising. Look at this epithelium. Usually in stratified epithelium, all cells are not of uniform shape. Look at this epithelium. The basally located cells are columnar. The middle located cells are sort of round, cuboidal. The superficial ones are squamous. So what shall we call this? Shall we call it stratified squamous, stratified cuboidal, or stratified columnar? For this, there is an agreement where you need only to see cells located at the most superficial aspect toward the surface. So this one should be named as stratified squamous epithelium. So that's how we name stratified epithelium in our body. This stratified squamous epithelium again comes in 2 varieties, because some of them, especially those which are lining our skin, need to be very tough. Those which are found more superficially need to be very tough by having in them specifically many intermediate filaments linked with some additional proteins to give us a protective type of polypeptides named keratin. This keratin is important to offer mechanical protection to those exposed cells. So stratified squamous epithelium may have those superficial cells full of keratin. In this case, we name them keratinized stratified squamous epithelium. They look like this. But some others may not need this type of keratin. We name them as non-keratinized, non. K is missing here, non-keratinized. N-O-N-K, keratinized. K is missing. Non-keratinized stratified squamous epithelium, like in regions which are subjected to repeated friction. The skin is not subjected to repeated friction, but it is subjected to sort of mechanical, physical friction forces, but that's not repeated. If you make it repeatedly move your finger over a skin would be damaged. But this is not the normal friction it is subjected to. But we have our internal tubular structure, such as our pharynx, our oral cavity. When we are chewing, the oral cavity is subjected to repeated friction. When we are swallowing, bolus would move the inside the epithelium, causing some repeated friction. In this type of cases, the superficial cells should not be dried. When they are full of keratin, the cells are also dead. The cells are dead, full of keratin. So in those which are subjected to repeated friction, superficial cells not need to be dead. They should be alive, but they should be also wet. They shouldn't have to have keratin, but they have to have another way of protection. So they are non-keratinized. So under stratified squamous, you have 2 types, either keratinized or non-keratinized. Then add stratified cuboidal, add stratified columnar, so few in their location. So again, under stratified, how many types of epithelium do we have? 4 types. But in addition to this, we also have one type which is added to stratified epithelium. This type of epithelium changes their shape. They are lining distensible luminal structure, such as the urinary bladder, which, when it is full of urine, would be distended. When it is empty, the epithelium should be collapsed. So, because of this, the thickness of the epithelium and cells located in superficial aspect would change their shape. When it is empty, look at the relaxed epithelium is thick as if it is made by more layers, and the superficial cells are very swollen cuboidal type. But when it is stretched, the epithelial cells are fewer in stratification. They are more of flattened, so they look like in a transition of development. They look like a transition of development, so they name them as a transitional epithelium. Another thing why they name them transitional is because one of another feature of epithelial tissue, especially those type, is that they are easily changing from one type to another type. Mind you, I'm only lecturing focusing on those which are more common. You have to enrich this by your readings from different sources. So this could be just one evidence for this is that I didn't tell you, for example, one of additional characteristics of covering epithelium is that the cells could be changed from one type to another type. Like, for example, pseudostratified epithelium of our nasal cavity in repeated damage, like, for example, in chronic smokers, could be changed into another type. It could come to be stratified type, for example. So because epithelial, covering epithelium has such characteristics, when people looked at the urinary bladder, sometimes thick, sometimes thin, they thought that it is in a transition of its appearance, so they named it transitional epithelium. But that's not the case. It is not in a transition of development, but it is showing the state of tension it is subjected to because of its nature, whether it is empty or open. So you see, at least under stratified epithelium, you can name about 5 different types of covering epithelium. Under simple, you can name at least about 4 types of epithelium. So that's what I can tell you as to the covering or lining type of epithelium. And then I would pick another presentation which would show you about glandular epithelium. Uh, we have to take about 10 minutes break and come to look at the glandular epithelium. But before we dismiss this session, before the break, if you have any question, you can ask. Otherwise, as you might have already noticed, we are almost half the way of our lecture. I'm a little bit fast, I know that. That's again, as I told you, to compensate the time we lost before we begin. So saying this, if you have anything to ask, chat or ask. Otherwise, some of you who may not have such a question may leave temporarily for a break of 10 minutes. Now it is 11. Class will resume exactly 15 past 5:15 ክላሱን እንደገና ጀምራለሁ። ከዛ በፊት ተመልሳችሁ ግቡ። ጥያቄ ያላችሁ ግን ጠይቁ። Feel free to ask. I am now looking at the chat. There is no one. Oh, maybe there is. Okay, it was down here. We are in the library. I can see we are all muted. Sorry about that. We are in the library, so we cannot chat. Most of us we are library. Please resume. Library found in the library. Are transition epithelium only found in you? Yes, transitional epithelium, not only urinary bladder, but urinary tract. The